Okay, in the previous videos, we looked at when we have a straight line function or an equation, how to get it from the equation bit and draw it on a piece of graph paper or the Cartesian plane. Now, we use different methods. We could use the table method or the dual intercept method or the gradient y-intercept method. Okay, so from the equation onto the Cartesian plane is kind of handled now. We looked at that. But now, if they gave us a straight line like this, and they asked us what's the equation of this line, there's kind of a way that we can do that as well. Now, usually we'll just use the gradient and the y-intercept. So they would usually, with straight lines, give us that information. So let's start off with the orange line. They say they want to know what the function is for this linear, the equation is for this linear function. Now I know it's going to be something like y is mx plus c, so it's going to be in that standard form. And the first thing that I can look at is the plus c, because I know the c is the y-intercept, and that's really easy to find. So because the y-intercept goes smack through 1 there, I can start off by saying mx plus 1. And now the only other thing that I need to figure out is what's the gradient. Now the gradient I can figure out just by hopping around. Now with these things, I'd usually on the line look where the grids or the grid lines are really like falling nice into place. So with the first line, it's very simple because, I mean, this is a very nice point where 1 and 2 gets together. That's also a very cool point. And this is also a very cool point. So I can start anywhere on the line. You can start at 1 if you want and jump up, but just because it's easier to draw, I'm going to start here. So I'm going to go up 1. And for a gradient, I know if I find out the gradient, it's the change in y over the change in x. And if I go up 1, that would be a plus 1. And to get back to my line, obviously I have to go right. If I go left, I will never get to my line again. So I'll have to jump 1 more. So that's plus 1 up and plus 1 right. Plus 1 right. So I see my gradient is 1. I could have done more jumps. I could have started here and said, okay, let's do 1, 2, 3, 4 jumps. And we could have said, okay, well, that's plus 4. And to get to the line again, we'll jump 1, 2, 3, 4. And we'll get to the same place, and that's also plus 4. And that would also be 1. So what we figured out is our gradient is 1. So for this line, our equation would be y is equal to 1, x. We don't really have to write the 1, but I'll just write it there anyway, x. And then the plus 1 we got from the y-intercept. So y is equal to x plus 1. Pretty simple. Okay, so let's look at the green one. The green one, green line would also have y is equal to mx plus c. Can you actually see that color? It looks okay. Sorry, let me just see if I can get it darker. And then the c is the y-intercept, and I can read it off here as -5. So y is equal to mx minus 5. Remember, it's a minus because it's down here, a negative number. But now I want to find the gradient. Okay, so here is a nice spot where, you know, it's kind of on a grid line, vertical. But here I'd have to guess. Would you see if I jumped up 1 and I jumped back a little bit, I don't really exactly know where that is. It's obviously not a half, but it's definitely a little bit less than a half. If I jump twice and I jump 1 back, I'm still not exactly on a grid line there. I'm going to have to guess an estimate and say I'm jumping back maybe, I don't know, 3/4, I don't know. And so I'm going to look for a nice place where I can jump and get exactly into, you know, a nice integer number. I don't have to. If it was like a half, it would be fine, but none of these look like I have to guess a bit. So this is a bit of a more tricky one. So if I go there, that's not going to work. Oh, that's going to work very nicely because that's a very nice. I mean, if I go down there, I can see these are integers. So basically, I'm going to have to get from here to there. So for my gradient, it would be the change in y over the change in x. And let's do y first. So I'm going up 1, 2, 3, 4, 5, 6, 7. So that would be 7. And that's plus 7 because I went up. But now I'm going to have to go back 1, 2, 3. So that would be, oh, that was a plus 7 and a negative. Oh, I'm definitely going to get a better green marker. So we went up 7 and we went back by 3. Okay, let me not use the orange again. Let's try the purple. Sorry, guys. Okay, so y is equal to, I found out it's 7 over 3. 7 over 3x, and then minus 5. So it's pretty straightforward. You just look at the, where it intercepts. Usually, if you're lucky, you get a nice integer number and not like a fraction like 1.5 or something. And then you kind of just find a nice gradient for your jump. And this is good. You don't have to write this as a, if you wanted to write it differently, it's fine, but this should usually be good enough. 2 1/3 x minus 5 would also work, but both would be fine. There's only, like, the other ones are really simple. So if we had a very special case like this, so we had a line like this, that's a special line. So what would the equation be? Well, if I go the long method, what would the coordinate be here? Let me just find my pen. So if I wrote this with special lines, I can kind of have the idea of what's the coordinate here. That would be 5, 4, and a coordinate there would be 5, 3, and the coordinate here would be 5, 2. So I see, oh, this stays the same. So this is just x is equal to 5. That's the equation. Pretty simple, straightforward. And if I had a that's a vertical line. If I had a horizontal line, let's do one here and just a normal red pen. If I had that one, I see the y value is the same all the time. So this is y is equal to -2, because y is -2 here and there and there and there and there and everywhere in between. So these are special lines. Okay.